Hey everybody, back with more GCSE maths hard today. We're going to do the sine and cosine rule after doing trigonometry last week. And you're probably wondering what the hell I'm talking about because sine, cosine, and tan can only be used in right angle triangles. But that is the start of today's lesson. We're going to learn how to use the sine rule, and more importantly, where to use the sine rule and the cosine rule and the various uses. We will learn how they applied, and then we will do our examples. And in class on Tuesday, we will also do how we use the formula for finding the area of any triangle, no matter the shape or size. Mm. We'll come back to that. So, the objectives today are we're going to know when to use the sine and cosine rule, and then how we use it and how we apply it. Okay, so the first thing is we're going to have a checklist. First thing you're going to check when you're looking at one of these questions is the triangle right angle. If it's a right angle triangle, then happy days. We don't need the sine and cosine rule. We're going to just use trigonometry rules that we did last week, or good old SOHCAHTOA, or Pythagoras' theorem. If the triangle is not right angled, you're going to use the sine and the cosine rule. Right. And what's it used for? Well, it's generally used to find out, much like trigonometry, missing angles that we don't know, or missing set lengths of sides. Sorry. So the easier one of the two is the sine rule. And here we have a triangle that is not right angled for a start. It's a scaling triangle. Okay, so discovered last week, and we're just going to label it A, B, and C, the three sides. Okay, and much like trigonometry, much of the hard part of the sine rule and the cosine rule is labeling your triangle. So if you have side A, side B, side C, we're going to, well, sorry, ABC is their points, sorry, with their angles. So that angle BAC we're going to call angle A. ABC will be angle B, and BCA would be angle C. The sides ABC are the ones that face those angles. Okay, so side A is the one facing side A. Side B is facing angle B, and side C is facing angle C. Once we get those done, then we just look at the formula. And in any triangle ABC, A divided by sine A equals B over sine B equals C over sine C. It can also be used the other way as well, upside down. Sine A over A, or sine B over B, or sine C over C. Now you're probably looking, this is weird, because there's two sets equal signs here, and you never see sets equal signs. Well, as we will see here, when we come to use it, we'll see how we use this and how the two equal sign come into play. Okay. So important to remember, you don't have to learn the sine and the rule or the cosine rule, as in you don't need to learn the formulas. You'll be given them at the front of the exam paper, so you just have to know when and how to use them. And so we'll look at some examples where that's the case. Okay, the sine rule, here's our labeled triangle ABC. You can only use the sine rule if you have a matching pair. And what I mean by a matching pair is an angle and a side that we know. So like A and A. If we know A and A, we can use the sine rule. If we know B and B, we can use the sine rule. Or if we know C and C, we could use the sine rule. If we haven't got a matching pair, the sine rule won't work. If you have just one angle on or side of something else, you can use the sine rule to find out the other angles or sides. So here we go. We have a triangle. One side's 10, with two angles of 40 and 65, and we've defined this missing angle x. First thing to do, ask yourself, is it right angled? 60 and 45 is 105. It's too big to make that 190, so it isn't right angled. We're okay. Next thing, is there a matching pair? Well, there is. The 65 and the 10 are a matching pair. They face each other, and you should label your ABC or whatever. There you go. We're going to use the sine rule, label the sides and angles. So we go A, B, C at the angles, and then subsequently our side A faces angle A, side B faces angle B, and same as C and C. We use our formula, and we substitute in the values that we know. So we know the length of A is x, and sine of the angle is going to be sine 40. Now it popped up on the right there. Because we are trying to find a missing length of a side, it's best to use the little letters on top rather than the other way around. If you were looking for an angle, you'd probably be best having the sine A or sine B or sine C on top. It would make it a bit easier for you, but these are also good at rearranging your algebra. It wouldn't really matter either way which way you did. So we'll put in our values. We don't need the C part of the formula because we don't know length of side C or the angle, so it becomes irrelevant. So if you cover that bit up, all you're left with is a simple equation with only two sides. And the reason that there's 3 bits is just that once you fill in your values, you will realize that one of these parts isn't necessary, or certainly not necessary at the moment, and you can use this to work it out. So if I take just that part of the formula and fill in the bits you know. So A is x, and like I say, the angle is sine 40 equals 10 over sine 65, which is this angle. We rearrange the formula and we'll get x equals 10 sine 40 divided by sine 65. We plug all that into your calculator and you should get 7.09, and it should be centimeters. And that's how you use the sine formula, or the sine rule, so to say. The formula for the sine rule. We'll look at another one. So here we've got a missing angle. We know two sides, but have we got a matching pair? It's not a right angle triangle. Is there a matching pair? There is the 65 and the 10 again. Again, an awful lot of these will say not to scale, so that the angles don't confuse you, they don't look right. So we're going to use the sine rule, but this time we're going to use the one with the angles on the top. So we'll label our diagram ABC and our subsequent side A, B, C. And we use sine A over A equals sine B over B equals sine C over C. Well, again, we don't need C because we don't know either the side of the angle. So we're going to get rid of that. And we're going to substitute in our values. So sine A is sine theta divided by 7.1 equals sine B, which is sine 65 over 10. And if you pop that in, we should get the reverse kind of what we did before. We get 0.64344785, and then when we get sine theta equal to that, we do our shift sign, and we get that angle to be 40.05 degrees, which was the same as what we got before, except for the wee bit around it. But 7.99 went up to 7.1 here, but the original angle was 40 in the previous question. That's the sine rule. And fairly straightforward. And it's by far and away the easier of the two rules. Cosine rule is what we use when we have all other triangles. So if the triangle is not right angled and there's not a matching pair, use the cosine rule. Here's a triangle ABC, ABC. This is the formula. A squared equals B squared plus C squared minus 2BC cos of A. There are also different versions of it. What if you need to work out cos of the angle B, right? Well, this letter will match the number that's before it. So if the A is the angle, it'll be A squared. So if it was B, what we're looking for, the angle B, it would be B squared equals the square of the other two sides, so it would be A squared plus C squared minus 2AC cos B, and C squared would equal A squared plus B squared minus 2AB cos of C. And you'll see those listed out, and we'll see them in the example here. Here is our first example. Find the missing side. Okay, so we have no matching pair. We have a 20 in what we're trying to find, but they're not matching because we don't know both of them. So we'll have to use the cosine rule. It's not right angled. There's no matching pair. Away we go. Label the sides A, B, and C, calling the given angle A and the missing side A. Well, we'll see in class how we get around that if you make a pillars of that. But for the moment, we'll do A, B, and C. So A is the angle we're trying to find, and A is the missing side. B and C. Okay, so the formula looks like this, and we're going to fill in the bits that we know. A squared, that should actually be x squared really, because we're replacing the A for the x. B squared is 12 squared plus 9 squared minus 2 times 12 times 9 cos of the angle 20. When you're doing this, be careful. Modern calculators might be able to handle this bit alright if you put it in just as one bit first, but I would generally do minus 2 times 12 times 9 times cos 20, and then add on your 12 squared plus your 9 squared. You will find that most mistakes that you make in cosine rule once you've done it right are of the variety of putting your numbers in wrong. So, that gives us a squared equals 22.026. So a is the square root of 22.026, which is 4.69, and that's your missing number. So when we're doing this, get your calculator out and put these numbers in and see if you can get the same answer. Let's do another one. This time in the form of a question. A man starts at the village of Chartham and walks 5 kilometres due south to Aylsham. Then he walks another 8 kilometres on a burn of 130 to Barham. What is the direct distance between Chartham and Barham in a straight line? So we'll need to draw this diagram out. First, draw a sketch. So C is Chartham. Okay, he walks 5 kilometres due south. There's your 5 kilometres to Aylsham. So Aylsham begins with A. We'll call that A. He then walks another 8 kilometres in a burn of 130. Now, if you're not sure about burnings, I'll attach another video, probably not mine, to the notes here, just to give you a heads up. I have a really lovely PowerPoint that walks you through burns. But burns are just the angles measured from north in a clockwise direction. Okay, so that would be like your starting point, and we're going to measure a 130-degree angle round like that. And that's going to be 8 kilometres long, and that'll be to Barham, which is B. And to complete a triangle, we'll just join the other sides. And there is our triangle. So we'll label our sides A, B, and C. It's not right angled. There's no matching pair. We're going to use the cosine rule. We're going to label the triangles, or the sides. It doesn't matter what way round B and C go. And we're going to fill in our values. A squared equals 5 squared plus 8 squared minus 2 times 5 times 8. Cos of the angle 130. When you pop all that into your calculator, you should get 11.85 kilometres. What do we find the missing angle? Is it right angled again? Doesn't look like it. Matching pair? No. Use the cosine rule. We're going to call our sides A, B, and C. The missing angle is going to be A, and then we'll label our sides appropriately A, B, and C. And we'll look at our formula. Now, when we put in our values now, we're going to be left with cos theta on its own. We will have to rearrange this equation. So first thing we're going to do, we're going to square all the bits out. 9 squared is 81, 6 squared is 36, 10 squared is 100, and minus 2 times 6 times 10 is minus 120 cos of theta. If I group those two together, I get 136. I can then bring it over to the other side. The 81 becomes a minus 81, and the 120, etc. goes like that. Now, they've rearranged this slightly. They've changed the order of the top two, but you probably have 81 minus 136 divided by minus 120. That will work exactly the same as this one. They have just done multiplied the top one by the minus 1 and taken away from the bottom. But you should get 81 minus 136 divided by minus 120. When you do that, the cos theta equals 0.4583333, and you'll get shift cos to give you 62.72. And that's the end. That's the sine and cosine rule. We'll do lots of past paper examples, and yeah, we'll see how we get on. I'll see you in class on Tuesday. Any questions, drop me an email or bring them with you to class. Until then, bye.